In this video, we will be talking about unknown angles topic 2, angles in a triangle and the exterior angle theorem. So here we have several different angles to talk about and theorems to talk about. We'll draw a picture and then we'll talk about the fact or the theorem that goes along with the picture. So here in this first box we see angle sum of a triangle. So we're just going to sketch a triangle for the diagram. And I'm going to label the angles 1, 2, and 3. We know that the fact says the sum of all angles in any triangle is 180 degrees. So based off of my diagram, that tells me that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And that 180 comes from the fact that if you were to take all of the angles from that triangle and kind of cut them off and then match them up right next to each other, they would end up lying on a straight line, making a picture such as this. So again, remember supplementary angles on a straight line add up to 180. The second theorem is the exterior angles of a triangle. So here we're going to sketch a picture of a triangle, and then we're going to extend one of the sides of the triangle so that we have an exterior angle. And the theorem here says that angles 1 and 2 sum to equal the measure of angle 3. So the theorem or the fact on the right side says the measure of an exterior angle, angle 3, is equal to the sum of the measures of the blank angles. And in that blank we're going to fill in non-adjacent interior angles. So again, the outside angle, angle 3, the exterior angle, is equal to the sum of angles 1 and 2, those non-adjacent interior angles. Sometimes we refer to this as the inside plus inside equals outside theorem. Inside 1 plus outside, inside 1 plus inside 2 equals outside 3. Inside plus inside equals outside. The next theorem that we have is regarding an isosceles triangle. So remember, in an isosceles triangle we have two congruent sides. If two sides are congruent in any triangle, then the two base angles opposite those congruent sides are then congruent. So here we know that angles 1 and 2 are congruent. So here our fact or our theorem says that base angles, of an isosceles triangle are equal in measure. The last theorem that we have here is regarding an equilateral triangle. We know that in an equilateral triangle there are three congruent sides, therefore there are three congruent angles. So here angles 1, 2, and 3 are all congruent to one another. Because all angles in an equilateral triangle sum to 180, and we have three congruent ones, we can determine the measure of one angle in an equilateral triangle by doing some division. 180 divided by 3 leaves us with each angle whose measure is 60 degrees. So now we're going to take a look at a couple example problems. Number 5 here says, in triangle DEF, angle D is a right angle, and angle F is 12 degrees less than twice the measure of angle E. Our goal is to find the measure of angle F. So first I'm going to start with a sketch. I have a right triangle where angle D is the right angle, and then the other two are E and F. It says angle F is 12 degrees less than twice the measure of E. Now I don't know what E is, so I'm going to call it, I'm going to call it X. I don't know what E is, so I'm going to call it X. That means that I can now call F something in relationship to X. Because remember, F is 12 degrees less than twice E, and E was now called X. So now I have twice X with a 12 degrees less than, so 12 degrees less than means to subtract it. So here I've got 2x minus 12. Remember that theorem says that all angles in a triangle add to 180. So we're going to take a second to write an equation, then we're going to solve it. X plus 2x minus 12 plus 90 equals 180. Okay, so take a few minutes to solve that equation. At this point, you should have found that x is equal to 34. However, our goal, remember, is to find the value or the measure of angle f. So I need to plug 34 back in to find f. Measure of angle f equals 2 times 34 minus 12 for a total value of 56. So the measure of angle f is 56 degrees. In question 6, we have an isosceles triangle ABC. So I'm going to start by sketching an isosceles triangle. Remember, that's where there are two congruent sides. Because there are two congruent sides, there are also two congruent angles. The vertex angle C. Now when it says a vertex angle in an isosceles triangle, that's referring to the one that is not one of the congruent angles, meaning it's the one at the top. So vertex angle C is 20 more than twice the base angles. Because we know nothing about the base angles, we're going to call them x. Just like we did up in number 5 for angle E. We didn't know what it was, so we called it x. Now because the base angles are congruent, I labeled both A and B as x. Now I know that the measure of angle C is 20 more than twice the base angles, so 20 more than 2x. That means that C is now represented by the expression 2x plus 20. So now remember, based on what we did in number 5, we know that all three angles add to 180. So I'm setting up an equation, and then you're going to pause the video so that you can solve it. Your goal in the end is to find all angles of the triangle. So once you've solved, check your answer with mine, and then move on to finding all angles in the triangle. Okay, so I found x is 40. Now my last task is to plug it back in. Because I know that both the base angles A and B are the same, they're both x, I can immediately write that down. So both A and B are 40. And then for the measure of angle C, I'm just going to do the work off to the side. I have 2 times 40 plus 20 for a total value of 100. And moving on to the next page, we see that here we have a diagram below of triangle HQP where side HP is extended through P to T. The measures of the three angles are given and they're written in our diagram so we don't have to label them. But our goal here is to find the measure of angle QPH. So if I follow Q to P to H, I see that this angle has no expression here. Because I already have used X, I'm now going to call this Y. So in the end, I want to find out the measure of angle Y, or angle QPH. If I look at this diagram, I see one angle inside, a second angle inside, and then a third angle on the outside. This takes us back to our exterior angle theorem, where we know that the inside plus inside can be added and set equal to the outside. So here I'm going to take x plus 40, add it to the other inside angle, 4x minus 5, and set it equal to the outside angle, 6x plus 20. So at this point I would like for you to pause the video to solve this equation for x and then check back in with me. So here I found x is 15, but remember our goal in the end is to still find the measure of angle QPH, which I've also again labeled as y. So now I'm going to remember what we talked about earlier, where we know that on a straight line, two angles add up to 180. So here I have angle QPT and QPH that are supplementary. So I'm going to start by writing an equation, taking angle QPT, 6x plus 20, and adding it to my y, angle QPH, and setting it equal to 180. But remember, we do know what x is, so I'm going to substitute that for the x in my equation. So I have 6 times 15 plus 20 plus y equals 180. Take a minute to solve for y in this equation. Okay, so you should have found that y is 70 And now, going back to write our final answer, we have measure of angle QPH is 70.